So formulas for systems of equations. That's a review from lesson 62, which we did right before the break. And then phase shifts and period changes. What is that going to be talking about? Sinusoids. Okay. So first we're going to look at the systems of equations. Do y'all remember your systems of equations that are composed of only abstract coefficients? We did that on lesson 62. So when we had a problem, what did they ask us to do? Solve for x or solve for y. Okay? So given these two equations, we can make a formula to solve for x. That's what we did in lesson 62. If you go through all the work, and you end up with x equals some random combination of variables with subscripts, and you'll end up with y equals some big random combination of variables with subscripts. But do y'all remember that step? So that's your formula to solve for x. Given that this is your A1, your B1, your C1, A2, B2, and C2. So we're going to do an example to find the formula for our y. So we want to use abstract coefficients to find the formula for y. And then we're going to use that formula to solve for y in this system that they give us. So it's a two-step problem. So to find the formula for y, we're actually going to use this system of equations right here. So how would we solve that equation, or that system of equation for y? What are we going to do? We want the x's to cancel. So what does that top equation get multiplied by? A2. And what would the bottom equation get multiplied by? Negative A1. Just somewhat coming back to you? So our top equation, when we multiply everything by A2, is going to be A1, A2x plus A2 B1y equals A2 C1. Go with me? And then the bottom equation, negative A1 A2x, negative A1 B2y, negative A1 C2. And then when we add them together, what happens to our x variables? They disappear, which is what we wanted, right? Because we're eliminating them. And then we have A2 B1y minus A1 B2y equals A2 C1 minus A1 C2. And then what do? Take out a y. So you have y A2 B1 minus A1 B2 equals A2 C1 minus A1 C2. And then you divide. So A2 C1 minus A1 C2 all over A2 B1 minus A1 B2. And that would be your y formula. So going back up here, it said find your formula for y, which we found. Use that formula to solve for y in this system. So I'm going to move my formula up here. over. Okay. So A2. Which one of these is my A2? C1. What is my C1? This was A1, B1. That's our C1, the 8. Minus, what is my A1? 3. What is my C2? It is also 3. What is my A2? What is my B1? What is my A1? And what is my B2? And now we simplify it. 32 minus 9 over 8 minus 15. What is 32 minus 9? 23. What is 8 minus 15? So y equals negative 23 over 7. And that's your answer. That, along with your formula that it said to solve for. So that seems like a lot of work. It's mainly just a lot of writing. On your homework, number 17 will say solve for x using the abstract coefficient. And then number 18 says use the result of problem 17 to solve for x, and it gives you the actual numbers. So this would have been one problem to get to the formula, and then the second problem would have been that. So that's 2 problems on your homework instead of having to do it all in one. Does that make sense? Any questions on getting to here? The hardest part for me is going from this formula to plugging in the numbers, because they don't always use A1 and A2s. They'll use like random letters, and so you have to go back and you're like, okay, E was here, so E is 7. That's the hardest part for me, but I don't know, maybe it won't be for you. Okay, looking at those 2 equations. What did we do for the bottom equation? We factor out a 2. It means the same thing, right? The top equation was unfactored, and the bottom one we actually factored out that 2. For our sinusoids, we want to write it in factored form. We don't want to have it unfactored because of the information that it gives you. In both of them, you can tell that your theta is multiplied by 2. You have a 2 theta, and then you have a 2 times theta. It means the same thing. But for the unfactored, you have a minus 90 degrees. We can't exactly tell what our phase angle is on that one, but whenever it's factored, we can easily tell that the phase angle is a positive 45 degrees because it's theta minus 45 degrees. Remember, the sign is always opposite. So whenever it's in factored form, you can tell the number that it's multiplied by, the coefficient, and you can also tell your phase angle. So anytime it gives it to you unfactored, go ahead and factor it out before you do anything with it. Whenever you write your answer, you're going to want to write it in the factored form. You don't want to unfactor it. Okay? So the coefficient is 360 degrees divided by the period, if it's in degrees, or 2 pi divided by the period in radians. That's just a review from before the break. Your coefficient is 360 divided by the period, or 2 pi divided by the period, depending on whether it gives it to you in degrees or radians. So if our coefficient is a 2, that means that 360 had to get divided by what? The coefficient is 360 divided by the period. So what did our period have to be? 360 divided by what would give me a coefficient of a 2? 180. So that means our period was 180 degrees. So if we're looking at our little sinusoids, from here to here would have been 180 degrees. And then from here to here would have been another 180 degrees. And so this is a total of 360. And remember, in 360 degrees, it went through 2 periods, which is what we have, 1 and then 2. That's what we did on a previous lesson, but do y'all remember doing that? Somewhat. Barely recall it. Okay, so a little bit more review on sinusoids. The phase angle for a sine function is the angle where the graph is going up. So this would be whatever our number is. We don't know how often it's repeating, but the angle minus 90 degrees. Do you remember that? And then for cosine, it's at a maximum. So when we go to our maximum, it's 120. So theta minus 120. You remember it's always minus and then whatever the angle is. So if this had been a negative 90, that would be a positive 90. And if this were a negative 120, that would be a positive 120. You always want to find the maximum that is closest to the origin, whether it be on the negative or the positive side, and you want to find where it's going up, again, closest to the origin. Do y'all remember this information too? Sine is always going up, cosine is always at a maximum. Your argument always displays the negative of the phase angle. I already talked about that. If it was 90 degrees for our sine example that we just looked at, you're going to say theta minus 90. And if it was 120 degrees for our cosine example, theta minus 120. Do y'all remember CASPA? Center line, amplitude, function, period, and then your angle. If you use those 5, it gives you all of the parts for your sinusoid equation. So using CASPA, you get the whole equation. There's nothing else that we're going to add to a sine or a cosine equation. Those are the 5 parts. Okay, so we want to write both the sine and the cosine equation for the sinusoid. So do y'all want to do sine or cosine first? It doesn't matter which one. Sine? Okay. What is the first part that we do? What is our center line? What's halfway between 7 and -1? What is 3 plus? Okay, 3 minus 4. You can see that one. So our center line is 3. What is our amplitude? What did we just add and subtract to get to the top and bottom? 4. Okay, and then y'all said sine. So we're going to start with sine. So that's the A and the F. What about that P? What does the P stand for? Period. How do we do period? One little wave, okay? So I'll start here at 225, and then where do I end? How far is that?
Five.
540. So how do we get the actual number? The coefficient is 360 divided by the period. Oh, whoops, I went too far. So 360 divided by, what was it? 540. What is 360 divided by 540? 2/3. Oh, not theta. X. And then we're going to say minus some angle. Well, for sine, where is it going up? It's going up at 315. Where else is it going up? -225. Which one is closer to the origin? Okay, -225. So this becomes a plus 225. So that's the first equation. For the next one, we're going to do cosine. What is the center line? What is the amplitude? What is the period? Is it still 2/3? Yes? The only thing that changes is the angle. So that's good, huh? So we want it to be a maximum. Where are our maximums? -630, -90, and 450. Which of those are we going to use? -90. So it's going to become plus 90. And those are your two equations. So the only thing that's different are these two numbers right here. Everything else stays the same. Well, except for sine and cosine. Do y'all see how that works? Any questions there? Okay. There weren't any to omit on your homework. So I've got some things to pass out for y'all.